Let's look real briefly at the following example. In a previous investigation, we thought about tossing a ball up into the air and tracking the ball's height above the ground as a function of the elapsed time since the ball was thrown. We can let h represent the ball's height above the ground in feet, t represents the elapsed time since the ball was thrown, and h is a function of t, and we can call this function f. So f of t is equal to h. And let's consider the following scenario. What if we want to measure the ball's height above the ground in some other unit, such as inches? So let's let capital H represent the ball's height above the ground, but this time in inches. We'll let the function n model a relationship between big H and t, so that n of t is equal to big H. For the first question, let's interpret what each of these equalities represents. So if f of 1.5 equals 33, we know that the input to f is t, or a number of seconds, and so this input represents that 1.5 seconds have elapsed since it was thrown. The output of f represents the ball's height above the ground in feet. So this 33 represents that the ball's height above the ground is 33 feet. So if we look at our options, we have two of them that refer to 1.5 seconds after being thrown. But the only difference is the reference to what the unit of measure is. In this case, we know that 1.5 seconds after the ball has been thrown, it's actually 33 feet above the ground, because the output of f is a height in feet. So in this case, this third option should be our correct answer. Now, n of 1.5 represents the ball's height above the ground in inches 1.5 seconds after it was thrown. Now, f of 1.5 is equal to 33, and so we know that 1.5 seconds after the ball was thrown, it's 33 feet above the ground. And 33 feet above the ground is equal to 33 times 12, 33 times 12 inches above the ground, because the number of inches in any height is 12 times as large as the number of feet in that height. So 33 times 12 is equal to 396. So n of 1.5 should be equal to 396. And this means that 1.5 seconds after being thrown, the ball is 396 inches above the ground. So in this case, the first option should be our correct answer. Now, if we want to fill in a table of values for any number of seconds since the ball was thrown, we can look at the number of feet above the ground, and we know that the number of inches above the ground should be 12 times as large. So in this case, it should be 12 times as large as 0, or when 0.65 seconds have elapsed, the ball's height above the ground should be 12 times as large as 32, or 12 times 32. And in general, the ball's height above the ground in inches will always be 12 times as large as the ball's height above the ground in feet. So we can use that way of thinking to determine which graph represents the new function, but let's skip past this question and look at the following one. Which of the following statements demonstrates the relationship between the output values of n, and output of n was in inches, and the output values of f, and the outputs of f were in feet? Now we know that the number of inches, which is represented by n of t, has to be 12 times as large as the number of feet. So the output of n should be 12 times as large as the output of f. And this is because there's 12 inches in 1 foot.